Hello and Happy New Year 2025. In this video, we're going to be looking at Incus 6.9, which is the first Incus monthly release of the year. I'm Stefan Greber. I'm the project leader for Linux containers and one of the maintainers of Incus. And this is the traditional video overview of Incus 6.9. So let's see what's new in this one. Obviously, it being the first release of the year means that the holidays kind of cut into development time, so there's a few less features than might be usual, but there's still quite a few interesting things in there. All right. So, first feature on the list is support for network ACLs on bridge networks. So, network ACLs on bridge networks are actually not particularly new, but up until now, the only thing you could do was apply an ACL onto the entire network. Now, with this release, we now have support to apply it onto specific network interfaces of the instances running on that bridge network. That effectively lets you do microsegmentation for a number of instances running on the same bridge. So applying specific firewall rules to specific instances, even though they are on the same network. That's very useful, allows for pretty fine-grained firewalling without needing to create many bridge networks. It's something we've supported for quite a long time now with OVN, but that has just now been added to also work outside of OVN with a regular bridge device. The next thing on the list are a few improvements to the QEMU scriptlet mechanism. So that's the kind of low-level interface we have to do pretty fine-grained virtual machine configuration, including setting up devices and kind of hardware layouts and the like that Incus itself would not normally put in place. And to kind of take that further, there's been a couple of changes to this feature. The first one is that now a full instance structure is always passed to the scriptlet hooks. That makes it easier to actually have the hook react to things like the list of defined devices or configuration or profiles, etc. that are set on the instance. And the second thing is a couple of 4 new functions as well as a new hook to actually control some of the QEMU invocation even before QEMU itself is started. So up until now, we had 3 hooks, I believe, pre-start, start, and post-start, where you could actually hook into the VM lifecycle to send QMP commands. In all 3 cases, the QEMU process was actually running, but the VM might just not have been started yet, or devices might not have been defined yet. And so you were able to send QMP commands to that and tweak it. Now, what we have is an additional hook called config, which is run before QEMU is started at all. And that hook then has the ability to use 4 new functions called get QEMU command line, set QEMU command line, get QEMU config, or get QEMU conf, and set QEMU conf. And that allows modifying, as the name implies, the actual command line of QEMU or the configuration file that we generate prior to QEMU starting. Using those commands, you can get the current config, you can alter it, you can set it back. And then shortly after QEMU is actually started, and then the other hooks are triggered as normal. Then still VM related and still kind of low level, another function that we have now is the ability to get a memory dump of a virtual machine. So that allows for pretty easy debugging or in some environments where you might have a crashed virtual machine or some kind of appliance, something running, and the vendor or your developer might need to get to see exactly what's running in there. So now it's possible with a hidden command called debug dump memory to actually dump the entire memory of the virtual machine into a file that can then be inspected. It supports a variety of formats based on what QEMU supports, but that's effectively a basic ELF dump or a Windows debugger compatible dump or Linux kernel debugging type dump. In the case of the Windows debugging case, you obviously need to run Windows and need to have the Virtual drivers correctly loaded into Windows so that the right memory mappings can be effectively shared with QEMU, which then allows putting the file correctly together. But using the function is then very easy. You just run the command that streams the memory dump directly over the network and onto the client that can then write it to a file for debugging. Next, we've got a small improvement to OVN. So up until now, if you wanted to know what IP addresses a given network was using on its uplink, you had to go and look at volatile config keys directly set on the network. That worked fine, but was a bit weird, and we usually don't like folks directly going to look or modify our volatile config keys. So that has now been effectively promoted to proper options directly in the state API and in the info command. So in this case, we can see here the uplink addresses are directly set. Next, we've got a small addition to the preseed logic, which now allows for creating volumes during initialization of the server. So you can use the preseed YAML effectively and define additional volumes in there that can then be attached to profiles or instances, or can be used for Incus on storage. And yeah, just feed that through Incus admin with the preseed option, admin init with the preseed option, and then that gets loaded. And lastly, a change to all of our create commands. That's probably going to be quite welcomed by quite a few people. Our CLI pretty much always shows a description column, but it's not always obvious how to actually go and set that. It could be done with the set commands and then asking it to set a property and description to the right value. But now it's much easier because at the time you create the object, you can directly pass -- description and the description you want and just get set at that point. And that's basically it for this release. There's a bunch more things as far as bug fixes, as usual, but for new features, that's effectively what we have. So now let's look at what can be pretty easily demoed. I'm not gonna cover all of the items, and not gonna go into super, like they're all the links to the documentation directly in the announcement, but we should be able to still demo a bunch of those. So getting a terminal up here. And the first one is the network ACL feature. So for that, it's pretty simple. It's actually what's in the release screenshot, but I can go and launch a new container here. Let's call it D12. Okay. So that container is going to start and then go online. Here we go. And if I go in there, everything is working correctly. So I can ping here. Can access the internet, can ping something, no problem. Now, if I want to restrict that, I can go and create a new network ACL. So let's call it demo. And then we can go and edit that ACL. And the first thing we'll do is actually for both ingress and egress, we can allow everything effectively. So it's like that. And if I were to apply that ACL, nothing would be different from what we have right now. That's kind of the default, everything is allowed. But now we can also go and actually reject some traffic. And that's where we can put like an IP address or network or anything we want. Can even be specific about the exact port protocol that we want. But for just rejecting an IP address, we can do it that way. Now that we have an ACL, we just need to apply it onto the instance. So we can override the network device on this one with security, ACL, and demo. And now if we go back in the instance, we can see that this is now blocked, but other traffic is still working as expected. So that's basically it. ACLs cannot just apply, they work fine. There are some kind of limitations with that particular implementation. Reject rules get turned into drop rules for traffic between instances on the same network, for example, due to limitation of how that works on Linux. But for the kind of most common behavior of wanting to control ingress, egress from the outside of the environment into those instances, that works perfectly fine and works as expected here. Okay, just clean that up. All right, and on to the next one. So next one is the QEMU scriptlet. So for that one, let's go ahead and create ourselves another instance, this time as a VM. Okay, I'm gonna start a terminal down there, and so I can just see traffic that's going through. And let's do log level error, and I only want the logging. Okay. All right. So the VM is running right now. I can actually go and stop that, and then edit the VM to go and add the scriptlet in there. So QEMU scriptlet, QEMU. Trying to remember just off the top of my head what the options are. I'm not sure I will actually get that right, but let's see. So instance and stage. Okay. And so that got set properly, which is more than I expected, honestly. And yeah, it worked properly. Okay. So at this point, we just have a basic scriptlet, and what it's done is at each of the hooks, so we can see this is called with stage config, so that's before QEMU started. Then you've got the same thing with early, so that's when QEMU started, but none of our devices have been put yet. Then pre-start is when all of our devices have been defined, but the VM is not running yet. And then post-start, which is immediately after the VM has been started. So for all of those, that shows us now the instance details, so we can see like all of the configuration and devices and everything's in there. Okay, so that's one of the additions, which was the instance part of it. Now, for the other part, and we can actually do, let's just not dump the instance anymore. We can do stage. And for example, we could do the command line. So if we do command line, and we just want stage, and then get QEMU command line. Right, I should stop it, but then it's gonna complain about change of state. Yeah. All right, let's go do the change again. So I want to always see the stage, and then dump the command line. So stage and command line, get QEMU command line. Here we go. If we start that, now we can see the different calls. They actually shows us the QEMU command line arguments directly right there. And it's given as a Python list, so it's pretty easy to actually go and modify things in there if we wanted to. So one thing you could do, for example, is locate the SMBIOS option and then change the motherboard manufacturer, for example, from Linux containers Incus to something else. So you could do it that way with the matching set command. Now, the other thing we can go look at and that you could mess with effectively is the config itself. So that's going to be a lot more data. So let's get QEMU conf instead. I don't know if yeah, I did stop the VM. Good. All right. So if we start it back up now we're getting a lot more data here. But that's effectively a Python list of dictionaries that defines all of the different entries that makes up the command, the actual config. So if we go look at the resulting config, the VM is D12. So QEMU conf is here. That's effectively this file, but in Python format, so that it can also be directly altered by the scriptlet by effectively getting the data, modifying it through Python loops or the like, and then using the matching set QEMU conf option to go and push it back into Incus. As a reminder, like we've seen it at different stage. If we go back up, so this is here we've got stage config and then early, pre-start, post-start. You can access the data in all four of them, but the only one where you can modify it is config. And config is the only stage where you can't send QMP commands, which is the other thing that the scriptlet can do. But that's basically it for how to do pretty low-level interactions with QEMU for virtual machines. Now, still on VMs, the new feature is the ability to do memory dumps. So for that, we can do QEMU debug, dump memory, and the help message actually has some examples for the different formats that can be done. So those are the kernel dumps that are more Linux type stuff, and then for Windows, we can do win dump. So if we want a memory dump, we can just do debug dump memory, name of the VM, so we can do D12 and just put it into a file called debug. And by default, the format will be an elf dump. But we could also do, in this case, a kernel type dump compressed. So it's going to be a kdump formatted, compressed with zlib. And there we go, flatten kernel dump v1. And we could do it in raw. No, that went way too quickly, so that probably got us a QEMU error. Kdump raw formats require a seekable file. Yeah, so the raw format is actually not an option in this case. Some of those vary obviously based on the guest running and whether they've got extensions, like the right drivers and everything running. As mentioned, like one of those that won't work is Windows. So if we do win and dump, same thing. It completes immediately, but the dump file actually has an error coming from QEMU saying invalid VM core info node size. That's a weirdly worded way of saying that this VM is probably not running Windows or doesn't have the right drivers running, so it doesn't have the data to actually dump it in a usable format. All right, so that's how to handle memory dumps. And next up is oven related. So for that, I need to actually look at a remote network, at a remote Incus. I can actually configure it, talk to a cluster, and then do the demo project. There we go. So if I look at the list of networks here, I've got a couple. And if we look at the info, that's where we now have those two fields. In the past, you would have needed to actually do use the show command and then go look at those config keys instead. But now it's nicely exported directly as part of the state info right from the start. For the preseed, I don't really want to go through the whole setting up Incus just to show the preseed and how that works. But the documentation conveniently has an example of what that looks like. So if we go look at the documentation, there's an example here for the list of storage volumes. This would define a new volume called myvol with within the pool called data. And obviously the pool called data was defined earlier. So that gets you a volume. In this case, it doesn't have size or anything set, but you could set that to through the config. All right. And the last thing is the ability to set description on. Actually, I just want to go back to my local machine, but to set description on objects directly at creation time. So yeah, I'm back on my own system here. And you can see already the example I used in the announcement. But basically, if I wanted to create a new profile, call it demo, and put a description that says my demo profile, we can just go and do that. And there we go. So that saves us from having to either use the edit command or use the set command to then go and set the description specifically. And that can go away. Here we go. So that's actually it for Incus 6.9. That's all of the new features. As mentioned, there are a bunch more bug fixes as well. Packages should start being available for most Linux distributions over the next few days. And that's basically it for this release. Next week, I'm flying over to Brussels for FOSDEM. So if you're in town, then come and say hi. I'll be running the containers dev room on Saturday and running the kernel dev room on Sunday. We also have a get together for those who are already in town on Thursday evening. So for that, it's just on our community forum. If you look for Friends of Incus, it's the way to find it. There's a post in our news section with some details and registration form there. So it's sponsored by Future Fusion. It's just an evening event, food and drinks, to chat about Incus ahead of FOSDEM. So if you're in town already, you might want to consider joining there. If not, and you're gonna be in town for FOSDEM itself, then you can come and say hi and stay and watch the talks in the containers dev room or kernel dev room over there. I'll be off the week after FOSDEM, so I'm effectively gonna be back to live streaming and all the stuff on YouTube on the week of the 10th of February. And that's it. Hopefully you enjoy Incus 6.9. If there's any questions or anything, feel free to leave them down below in the comment section or directly on the forum under the announcement. And thanks for watching. Maybe see you in Brussels. Otherwise, see you in the next video. Bye.